Hello class, good morning. Can you hear me?
Good morning, teacher.
Yes, good morning to you too, Intung. Can you hear me loud and clear?
Yes.
Okay, thank you, Jahoy. Hello, Intung. And then I think maybe still your friend are still coming in. So I think now is, what is the time now? 9:18. So I think I can start now, yeah? Yeah? Okay. Hope you are all ready, yeah? All right. Can you see my presentation as well? So I will show, sorry. I will show you my presentation right now. Make sure you can see my screen sharing, yeah? Right now. Okay, can you see it now?
Yes.
Okay, very good. So you can later, like usual, refer to your textbook also. This is page 170, 150. Okay, the relationship. So the topic for today is the relationship between current, voltage, and resistance. Okay, the relationship between three unit of what we call how to measure the quantity of electricity. Okay, current, voltage, and resistance. Right. The important thing, because last time we already learned about what is current and then what is voltage. Number two, how to measure current and voltage. Okay, and then number three, what is the meaning of current and then what is the meaning of the voltage. Okay, so if the question asks you what is the current, what is the voltage, it is one of the quantity. All right, you still remember the SI unit? This is the unit or the quantity to measure electricity. Okay, the two major, all right, the two important unit to measure electricity quantity, to measure the electricity is current and voltage. You must understand this. And then what is resistance? Resistance is the things, you just remember here, yeah? Resistance is the things or the material or the device that resist the current. Okay, resist the current. Okay, there are certain material and actually device they are using electric, for example, computer, battery, lamp, every device that use electricity, meaning that it has a resistance. Okay, any device, computer, television, radio, your handphone, okay, printer, every device that use electricity has resistance. Okay, so today we try to learn the relationship between these three units: current, voltage, and resistance. Meaning that what I mean here is what happened, for example, between current. I give you just one example first. For example, between current, very big one. For example, between the, for example here, between current and voltage. Why so big also? All right. So, between current. Between meaning that, between mean what? Between mean there must be two parameter. Okay. So, for example, between current number one and between voltage number two. So, what is the relationship? Okay. So, for example, number one is current. And then number two is voltage. So, what are the relationship? What are the relation between this unit? So, we have the parameter here. If I say, for example, if the current increase, so what will happen to voltage? Okay, this is what we call by relationship. All right. So in order to know what happened to the voltage? If the current increase, we need to do experiment. We need to do the activity. But like usual, I will try to explain the theory side of the activity first. Then, if we have time, we will try to do the activity at school. Okay? Can you understand this? This is what we call by relation. Relation. Current and voltage. And then number one, current and, if I'm not mistaken, the current voltage resistance in current. And then voltage on current. All right, current and voltage. And then number one is the current and resistance. There are two relationships lah. There are two relationships you need to understand here. All right, can you understand this? There is a relationship, meaning, for example, what happened if current increase? What happened to the voltage? So this is we need to know. Can you understand this, class?
Yes.
Okay, very good. Thank you. All right. And then, what is the meaning of resistance? Resistance means, I think we already do this yesterday. All right. The meaning of resistance is ability of the conductor, right? Ability of the conductor. This one. Ability of the conductor to limit or resist the flow of electric current. The ability of the conductor limit to resist the flow of the current. Because class, what does it mean? Not every conductor has the same flow of current. Okay? Not every conductor has the same flow of electric current. Okay? For example, between iron, okay, between iron and copper. Okay? You still remember iron and copper is what, class? Iron and copper. What is the iron and copper? It is what type of substance? Form 1. Is it metal or non-metal?
Metal.
Okay, very good. Iron A and B copper is the form of metal. Okay. What are the characteristic? One of the characteristic of metal is it can conduct or cannot conduct electric.
Can.
Yes, very good. It can conduct electric. But between iron and copper, not the flow of the electric current inside the iron and copper is not the same. It's not the same. Although both metal, iron and copper, can sure conduct electricity, meaning that if you try to connect to what we call use it as a as a wire, yes, you're able to conduct the electricity. Okay, but which one do you think has what we call less resistant? Is it iron or copper? Less resistant mean here the flow of electricity inside the metal here is what we call the current is more. Iron or copper? What do you think? Is it iron or copper? The flow of electricity, meaning that the flow of current has less resistance. Less resistant.
Copper.
Is it iron or copper? Anybody? You try to guess, Nabiman. Is it iron or copper? Yes?
Copper.
Yes, copper. That's why I will show the picture. That's why I will try to show you the picture. Most of the electrical, what we call the metal or the conductor inside the cable, most inside the cable, for example, this one, made from metal. Made from copper. This one. Okay? Made from copper. This is copper actually. Right? And then, because why? Copper, if you try to compare between copper and iron, okay, copper has less resistance, meaning that the current, the electric current, can flow through it more efficiently. And that's why we use copper. And then that's why if you try to buy, for example here, I will show you another picture. Okay, for example, this one. If you try to buy this one, this is extension cable. All right, this is extension cable. Sometimes if you try to buy this one, some what we call some brand very cheap one, and then some got very expensive one. Why? Because the material they use. If they use pure copper, it will be a bit expensive. But the quality is good because more what we call more current can flow through the copper. Okay, and then if you found the extension wire like this, very cheap one, what do you think? The material inside the wire, you think? Is it made from copper, you think? If the more cheap one, the cheaper one, this one? Do you think what is the material inside the wire? Is it copper or iron, you think?
Iron.
Yes, very good. Maybe they mix the copper. It is not pure copper, all right? Maybe they mix it with iron. That's why there are, different what we call price of extension cable. Iron. Okay, never mind, right? Can you understand this, But most of the small electrical, like here at your home, use copper, okay? But if the electricity is what we call a very big, you must use iron, because iron is less cheaper. Iron is cheap than copper. But if you want better quality, you must use copper because it has less resistance, okay? It has less resistance. Okay, very good. So we continue. So I will go to the, I will skip the experiment activity on the textbook here. And then I jump to the Ohm Law. Okay. Maybe we will do the discussion on relationship between current, voltage, and resistance when we do discussion on the workbook. Okay. So next one is the Ohm Law. Ohm Law is what we call, after you study what happened during the relationship between the current, voltage, and I, there is a calculation. There is a calculation that we call an Ohm Law. And then you must remember this formula. You must remember this formula. V equal to I and R here. Okay. V is what? V is voltage. Okay. V is voltage. All right. V here is voltage. I here is D. I will write here. Yeah. V is voltage. And then what is the unit of voltage, class? What is the symbol?
Capital letter P.
Capital letter V. Yes, very good. Thank you very much. All right. Capital letter V. And then how about I over here? I is represent what? Anybody? I represent the okay, never mind. Current. Okay. And then what is the unit of current? Hello? What is the unit of current? Can you hear me? Yeah, capital A. All right. Very good. A for ampere. Okay. And then V for volt. And then how about resistance? How about R? Okay, never mind. I'll just give you the answer. R is resistant. And then what is the unit of resistor? We call it ohm. Omega symbol here, yeah? We call it ohm. And then you must remember the formula here, meaning that voltage is equal to current times resistance. Okay, and then please do not confuse with A and I here. I is represent in the formula for current, and then A here is the unit of current. Can you understand this? A is the unit of current. A is ampere, and then I here represent the current. You cannot write VAR here, cannot, yeah? Insert in the formula, in the Ohm law, you must write V equal to I times R. And then I here is the current. Okay? So this, and then after this, we try to do the calculation first. Or you can remember by drawing a what we call Ohm law triangle. Ohm law triangle over here. So I try to zoom in a bit. This is what we call an Ohm law triangle. This one, can you see it? Can you see this? This is what we call by Ohm law triangle. Okay, very easy to remember like this. Because there is a relationship, because there is a relationship between the three unit. Okay, so this is what we call by the triangle, Ohm law triangle. Okay. For example here, VIR meaning that it is V at the top here. IR means times here. This is mean times. Okay. This is mean multiplication, multiple. And then this one is from the top side of the triangle, and the below side is you must divide it. This you must divide. This is also you must divide. Is it okay? Can you understand the Ohm law?
Yes.
Okay. Just draw a triangle. Okay. And then at the top, voltage. On the box on the left is current, and then on the box on the right is resistance. And then V is for voltage, and then the unit of voltage is V. Remember, I is the current, and then the unit of current is A, ampere. And then for R is resistance, and then the unit is omega. Or you call it, the symbol is, we call it omega, but you must write it ohm. You must spell or pronounce it as ohm, O-H-M. Okay? Never mind, later on we try to do the calculation. You just remember the Ohm law first. Okay. All right. So, I refer back to your workbook. Now it's what? 9:36. Okay. Your workbook, page 83. Okay, page 83. Now this is, we want to study, or we want to find out the relationship between, the first relationship between resistance and electric current. Resistance and electric current. Okay, and then I will explain to you by referring to the diagram on page 83, your workbook. Okay, what happened here? Okay, I hope you already understand the what we call the arrangement of these what we call electrical component. Okay, we have here, so we have here dry cell, and then connected to the ammeter, and then the ammeter connected to the nichrome wire. This is the special, what we call special apparatus we use in this activity. We have nichrome wire, and then nichrome wire here connected to the bulb, and then bulb right connected back to the dry cell over here. So my question is, what are the type of circuit is this? Is it a series circuit or parallel circuit?
Series.
This is a series circuit, right? This is a series circuit because only one loop. Okay, now I connect all of this like usual by using nichrome wire and everything. Okay, and then I try to switch on, or try to switch on the what we call there is no switch over here, but never mind. We try to nichrome wire. How to wait? I try to erase the nichrome wire name here first. So how to erase this? There is a white color. Yes, there is a white color. Okay, never mind. I try to erase this first. Just use the big one. Oh, all right. Okay, very good. All right. Okay. So again, this is nichrome wire over here. Yeah? I just make another line here. Nichrome wire. Okay, and then we have crocodile clip over here. I think I will erase it as well for you, for easier for you to see what is happening. Okay, I just erase it. Right. Okay. Okay. Now, the first thing you notice is it is not connected. It is not connected yet, right? Huh? It is not connected, right? The wire is not connected to the nichrome wire. So what happened to the bulb? The bulb is light or not lighted? Right now, if you see the diagram right now, light or no light?
No.
Okay, no light because there is no connected, right? Because the circuit is what? The circuit is what? The circuit is open or closed? This one, right now. Circuit, the open or closed? Close mean? Yes, class?
Cross.
Open.
Which one? One say open, one say close. Okay, in electrical terms, this means that if the wire is not connected to anywhere, we call it open. We call it open. The circuit is open. Okay, and then if the circuit connected right now, I try to connect the bulb here. Okay, I will try to connect the bulb here to here. Can you see my drawing? Okay. Now the circuit is closed. But never mind. In order to avoid confusion, never mind. I will just erase this. No need to know lah, open or close. Okay, no need to know about this. Right? Okay. Maybe you just write, okay, right now it is connected, right? Right now it is connected. Okay, you just remember that this is right now the circuit is connected. Okay, because the cable here, the cable wire here, right? The what we call connecting wire here is connected to the nichrome wire over here. Okay, so my question is, the bulb here is light or not light? Light or not light?
Light.
Okay, it will be light. Yes, it will be light. Okay, and then you also notice the what we call the length that I connect the nichrome wire over here. These are the length of nichrome wire I connect. Maybe about 1 centimeter. Okay, maybe about 1 centimeter. Can you follow me?
Yes.
Yes, okay. Because here we have two from emitter, we connect this and then this first, and then maybe the length of nichrome wire we use in order to connect the current is only 1 centimeter length in length. Okay, right? So the meeting of ammeter for 1 centimeter of connected nichrome wire, 1 centimeter, 1 centimeter of nichrome wire, the ammeter reading is about I give you approximate only, the what we call anggaran sahaja. Okay, 1 centimeter is about 0.4 ampere. Can you follow this? So the ammeter reading, if I connect just 1 centimeter, is 0.4 ampere. Okay, and then the metal bulb for 1 centimeter, for 1 centimeter of nichrome wire, the bulb is bright. The bulb is bright. Bright mean what? Very bright lah, very bright. Can you follow me?
Yes.
The bulb is bright. If I use just 1 centimeter, this one, 1 centimeter of length, because you can see the cable here, when I'm connected to the nichrome wire, I just use 1 centimeter of nichrome wire. And then the reading here said 0.4 ampere. Okay. Now, okay, can you understand this? Now the second step is, these are the second step. Are you ready, class? The second step is, I try to, white color. Okay. Sorry. Again. So this is the second one. The second what we call step. Okay. So the second step is, what happened? Okay. I move the connecting wire from here. I move it to here. Can you understand this? And then the length over here, from 1 centimeter, it will become about 4 centimeter. Okay, can you follow me, class? Is it okay? Okay. So 4 centimeter of nichrome wire, I write here 4 centimeter of nichrome wire, and then what is the reading of the ammeter? The reading of ammeter will become 0.1 ampere. 4 centimeter of nichrome wire. And then what happened to the what happened to the bulb? If I use 4 centimeter of nichrome wire, the bulb will be dim. What is dim? Dim is not bright lah. It will become not bright. So what are the relationship? Anybody? Meaning that what? Can you give a conclusion about this activity? Meaning that nichrome wire, for your information, nichrome wire is the wire has the material that can resist electric current. Okay, nichrome wire. Material that resists what we call that has the higher resistance of electric current. It still can conduct electric, but if you use it longer, it will resist more current. So this is what we call, this is the material inside the nichrome wire. Nichrome wire. Okay. So what is the relationship now? The relationship now. Relationship number one, if the resistance high, so what happened to the current? What happened to the current? Current if the resistance high, the current is what? Anybody? If the resistance high, what happened to the current? Is it high also? If the resistance increase, so the current is decrease or increase? Look here. Look here. Okay. Meaning that if I use 1 centimeter of nichrome, meaning that the resistance is low. If I use 4 centimeter of nichrome wire, the resistance is high. So if the resistance is higher, what happened to the current? Lower, increase or decrease? Yes, it become lower. Or you can write decrease. Okay, decrease. Right? If the resistance increase, the current decrease. Okay, depend on the length of nichrome wire here. Depend on the length of the nichrome wire here. Nichrome wire, if higher, if longer, meaning that it has higher resistance. Okay, you understand this? Never mind. Never mind. If you have any question, you can ask me later. The video of the recording I will upload like usual. I will upload it on the YouTube for you to see later. Okay, right. So what I need you to do, page 83, alright. Cara kerja itu, I think you no need to write lah ya, the cara kerja. Pemboleh ubah, you try to do the pemboleh ubah. You try to finish page 83 and 84 first. Okay, and then we will see you again for discussion on Monday. Not Monday. Monday, I think I have things to do. Okay, the next class, we will do the discussion on the next class. Okay. So for today, exercise, page 83 and then 84. You try to do the what we call the activity first, yeah, the exercise first. Okay, class? Is it clear?
Yes.
Okay. So I think now is 9:51. All right. So I will end the class here. See you all again next class, yeah. Monday maybe I have work to do on Monday, and then Tuesday, Wednesday maybe never mind. If I have changes of plan, I will inform you. Okay. So I think I will see you all again next class. That's all for today. I will upload the video later. And then question, like usual, ask me if you have any. Right, class? Thank you very much for your attention and focus. You can leave the class now. Bye-bye. See you.
Thank you, teacher.
Thank you very much. Thank you.
Bye-bye.
Bye-bye.